session about testing, which is always a topic that I like, but not all people love tests, right? Probably more of the things that I'm going to talk today, most of you will disagree, but that's great. Just remember this talk in 2 years when you are having tens of microservices deployed on your cluster. Then it's the time for watching this presentation. My name is Alex Soto. I work in Red Hat. I'm the curator of lordofthejars.com. And yeah, you can follow me on Twitter. You have any question, I will try to answer on Twitter. And at the end of the presentation, you will see my email. Also, I'm the co-author of Testing Java Microservices. So yeah, feel free to take a look. And if you have any question, please just raise your hand, and I will try to answer you. And if not, at the end, if we have time, also I will be very happy to answer your questions. First of all, I will start saying that software is hitting the wall. I mean, that we've seen several companies, for example, Uber, Just Eat, or, for example, I remember one interview with the CEO of Banco Bilbao Vizcaya saying that its virtual office is taking more requests than all the physical offices. So he agreed that nowadays, Banco Bilbao Vizcaya is a software company which does some banking things, right? So it's really, testing is really important in all our lives. And to make a quote of Spiderman or Justin Lee, I would say that with great power also come great responsibility. And I'm going to show you some examples. Notice first the date of this news. It's that 2015, right? And it said Windows 3.1 is still alive, and it just killed a French airport. And it's true. I mean that they need to manage all the, yeah? Question? No? Okay. Just we say, I don't know which is the question about 3.1, but yeah, who knows? Basically, they manage all the traffic using the, the manual way, because the migration from Windows 3.1 just crashed. There is another example. This is really funny, which is like $47 million slot machine win, blaming on software error. Casino won't pay. And if you read the news, you'll see that the Austrian guy who put the coin, it said, hey, I see this in the screen, and I thought, oh, what am I going to do with all this money? And then it came the manager from the casino saying, no, it's a software error, so we are not going to pay anything. And at the end, they paid like, I think that it says $100 for a meal, right? And yeah, for a software error. So yeah, so of course, we need to test correctly, because we have a great responsibility. And also, you need to use test not only for allowing refactor your code, but also to validate that what you are delivering is the right thing, and it's done the things right. And nowadays, in the, let's say, 21st century, there is a trend architecture which is called microservices, which basically it's something like this. You have your service, and then you have a lot of cross-cutting concerns, like discovery API, invocation elasticity, authentication, login, monitoring, tracing. I mean, that all these things has come with microservices. But one of the big advantages of microservices is that they can be deployed, on a scale in different business functionality in an isolated way. So you have several microservices, all of them interconnected with probably network. And this affects how we are going to test. Because now, if you think about how you test in the monolith, let's say, architecture, is that usually you have unit tests, component tests, integration tests, and so on and so forth, and then you have some end-to-end tests, which basically tests all the components in unison, right? And you have some regression tests, some smoke tests, and then when you are right, you say, yeah, everything's working as expected, let's go to production, and then you move this to production. So most of the companies that I've seen, they're trying to use exactly the same, but for microservices architecture. So what they're doing is say, OK, what we are going to do is replicate the cloud environment locally. And I mean to say, yeah, we have Docker, we have Puppet, we have Minishift, Minikube, whatever. I can replicate my cloud environment on my machine. And the truth is that this does not work. If you start with 10 microservices, probably it works. But if you try to start 30 microservices with all the databases and so on and so far, this is not going to work on your machine. And also, it has a big maintenance cost. I mean that it's going to start failing. You need to maintain these environments and so on and so far. So it's not easy at all. Another way that I've seen is like using a pre-production cluster, right? So you have your pre-production cluster, and then you deploy something there, your microservice with all the microservices, and you then start doing some QA test, which it might work. The problem is that if you are using manual test, your speed is not going to be really high, right? And also, there is a lot of cost maintaining these pre-production clusters. And also, I remember reading one study that says that in this stage of the application, you're only going to catch like 10% of the bugs. So you're adding an extra step on your deploy pipeline for just catching the 10% of the bugs. But what really happens with this environment is that you end up with flaky tests. So it makes you slow your pace, checking what's happening with these flaky tests, if they are real failures or they are failures because of network or because of disk or because of the cluster is not up and running. So it's not easy at all. So what I'm saying is that maybe if we are developing a new architecture, maybe we need to stop applying the old techniques and start applying new techniques for the new context. Obviously, replicate cloud environment approach is just wrong, because believe me, you're going to end up by just not executing this test. And let's say that the good way of doing this is just start considering that test was a pre-production activity, right? We test before we go to production. But maybe now, a test, it's time to move it on the production phase. So not just in the pre-production phase, but just also in the production phase. And this means that probably some techniques that fell into the release engineering umbrella now are meant to be tested. And this is where the controversy comes, and it's like, I like to call, or yeah, I mean that this approach of using a step-up rule. The step-up rule, basically, it's just say, OK, I'm going to get all the tests, and all tests are going to test one layer above what is the purpose of each of the tests. So for example, in unit test, let's use I/O. Usually, you mock everything in unit test, and I'm not saying that you don't need to do this, but just test as well I/O. For example, integration tests usually are run against a pre-production environment or a stage environment, but why you need to run integration tests on this environment? We said that it's not really good to do it. So just run integration tests on production test. Doesn't matter. I mean, that I'm going to explain you techniques to do that. And finally, probably what you nowadays are doing as production tests are going to become some kind of exploratory plus monitoring test. So this is the pyramid that most of you probably knows, which is provided by, well, I don't know if it was created by Martin Fowler, but I mean that the figure is taken from Martin Fowler's blog. But now, Cindy Sweethart mentioned that maybe it's better to read in that way. So it's not just a pyramid, it's just pre-production testing, where in this umbrella there is some contract testing, unit testing, integration testing against production and so on. And then there is another kind of tests that are run on production, like for example, exploration, monitoring, canarying, A/B testing, and so on and so forth. So now, instead of having this pyramid where you have a lot of unit tests, less component tests, UI tests, and so on and so forth, what you have is like a fuzz of everything, right? And so let's see a step back from now, and you can see that there are like two big groups of tests: pre-production tests and production tests. In case of unit tests, of course, you need to still use unit tests for design or as a design activity for your application. But again, you can also test I/O in unit tests. And notice that in case of microservices, I/O communication is really important, because at the very end, this is the main thing in a microservices, that your service needs to communicate with another service. So the first technique that I'm going to show you for unit tests is service virtualization. And it's not, it's nothing new. That probably most of you are using mocks, right, in your unit tests. So in your unit tests, you mock dependencies, collaborators. Let's say you mock classes. And with microservices, you need to mock services, not classes. And this is exactly what service virtualization does. And here I have an example of Java, but at the very end, it's more or less the same with any language. This is Mockito, where you define a mock, and then you just record the method expectations. You say that when I call this method, I want to return all this stuff. Then you do you write your test, and finally you say that you verify that this method has been called at least one, so you validate that this behaves as expected. How it works this with service virtualization? Because it's basically the same. You're defining a record service expectation. This is an overfly example, which is a Go library, but can be used standalone, but also provides a tight integration with Java. So you just say, look, when my service is going to connect to api.fly.com and using the get method with /API/bookings/1, then just return a success with this JSON file. And then I can just do exactly the same, which is verifying that my API using the HTTP client has make a request to, in this case, anything fly.anything in /API/bookings. So you can see that in case of service virtualization, is exactly the same as mock, but you are mocking services instead of mocking classes. Usually, I like to call it service virtualization as mocking for enterprises. But of course, the problem with mocks, and you find these problems with classes and also here, is that it's how you understand the system. So you are mocking a response that maybe it's not valid when you're running against the real class. In this, in microservices, happens exactly the same. You might mock the service response with a JSON, but maybe this JSON is not valid anymore. So all your tests will be green, but when you go to deploy this in against a real service, then you will get some failures. So the solution for this is contract testing. And contract testing is just a contract. It's an agreement between the consumer and the producer on how the API should look like. And this is how it works. Notice that there is a line in the middle. It's really important, this line. You have a consumer and we have a provider, so it's these two services that want to communicate. And the first thing that you do in the consumer side is define a stub server, like it happens with service virtualization. This can be understood as a light proxy. And you write some expectations. So you say, when I'm going to /API/flights, then return this. You write some expectations. And then what you do is just, from your consumer, sending some requests to this stub server. And this stub server will say, OK, you're sending me that you want to do a get in a /API/flight, so I return you this JSON. And then you do something with that. If the test is green, this will generate a contract. So this contract just will say, when I'm going to a /API/flight, then it needs to be produced this JSON file, and I'm green. It means that I can process this JSON file. And then you're going to publish this somewhere. It can be a shared directory, an FTP, or a file server. It doesn't matter. It's provided somewhere. And then it comes the provider side. Notice that in this way, the consumer are not starting the provider. It's isolated. Then what's happened? In the provider side, what you're going to do is just say, OK, I have a contract, and I want to check if the contract can be replayed against the provider. If it can be replayed, and the request and the response are the expected ones, then I know that when I connect the consumer and the provider, both of them will be able to communicate. If not, there will be some problems. This is what happens. You start replaying all the requests of the contract against the provider, and then you check the result. If all the requests and all the response are the expected ones, then it means that everything is fine, and you can just deploy to production. And there are a lot of tools about that. If you are using Swagger or the new OpenAPI, then there is a tool for OpenAPI, but also there is Pack Foundation, which is a foundation that offers you a JSON library for writing contracts for several languages like Go, Java, .NET, Sharp, and a lot of language, JavaScript, and so on. So contract tests and unit and service virtualization are two new tools that you should use in your pre-production phase. So maybe some of you know this image. So OK, you have your unit test, you have service virtualization contract test, you said everything works as expected, you put to production, and then? Yeah, it happens this. Yeah, it happens because productions have some uniqueness, like network setup, DNS, firewalls, databases, thousands of things that makes production different of pre-production, staging, your local development, even all your contract tests and so on and so far. So obviously we need to do something. And this is the first thing that you need to understand, and is that production is not sacrosanct anymore, so you need to be able to do things there. Of course, this requires a change on mindset, some appetite for risk, and changing how you develop code. So you need to develop code for failure instead of success. Usually you program for success. You said, I want to do this, try catch, and if it's a catch, I just throw the exception. This is not how it works if you want to test on production. The good thing about this is that no more staging, no more pre-production, you're going to save money. So there's several techniques for for testing and production. The first one is the blue-green deployments. And basically, it's that you have two identical environments, and you balance when you are ready. So basically, you have your SCM, you build everything, you have here your new microservice to be deployed, and you say, OK, currently, all my users are connecting to the blue environment. So it's reaching the blue, let's say, the old version of this service. So what you're going to say is, OK, now I'm going to have my build. I'm going to deploy this service as a green environment. And, you're going to switch back from blue to green. So now all your traffic are going to go to the green environment. So what you need to do in this case is just start watching your monitor and getting if the rate of failures are increasing or not. If it's increasing, it means that you have break something. So you need to go back to blue. So it's really fast to react. If it's working as expected, then you can just remove the blue environment. And you said, it's great, because I can switch back really quickly, because you have both services living at the same time. But it has a major error, this approach, and it's that if your green environment has an error and you switch from blue to green, all your users will notice the error. So maybe you're not so happy about that. So you need another technique. And this technique, it's called Canary Releases. I don't know if you know why it's called Canary Releases, but it's quite funny because it's regarding this mining thing, which basically in the past, the miners put a canary inside a coal mine, right? And in the coal mine, sometimes there are some toxic gases. So the birds die after 30 seconds of breathing these toxic gases, and the humans after 2 minutes. So the conclusion was easy. I put here the canary. If the canary dies, then I know that I have 1.5 minutes to go out of the coal mine. This is why it's called Canary Releases. And they do exactly the same, but of course not with animals, but with software. And you have, again, your service that you want to deploy. And what you're going to put is that all your traffic goes to the blue, to the old service version. And you're going to say, OK, now 100 of my users are going to go to the new version. And I'm going to start to monitor. If there is no increase in the error rate, then I can start 5%. If the 5% is OK and everything works as expected, I'm going to move to 25, 50%, 70%, until all your users are against the new version. So in this way, if there is an error, you're not affecting all your users, but just the 1% of the users that are reaching this new service. Of course, there are more, because now you said, OK, but you are affecting the 1% of the users. Of course, if on most of the cases, 1% of the users is going to be not so much. But if you think, for example, in APIs or in services like, for example, Twitter or Facebook or all this that has millions of requests per second, then 1% of the users are an amount of users, right? So there is another approach, which is called dark launches. And you can think of dark launches as a set of techniques to test on production, but without the end user noticing it. And I'm going to show you here 2 techniques. There are more. The first one is like the dark launch, where you have some internal users. So maybe you are also the user of your own product. So you say, OK, now I'm going to deploy this to my cluster, but only the internal users are the ones who are going to use this new service. The rest of the world is still with the old version. So my employees are going to test my application on production. And if it works, then I can switch or I can start the Canary Release. This depends if you want to do a blue-green after this or you want to do a Canary Release. This is one way of doing. The other way of doing is shadowing traffic. This is another way, which is like, OK, I'm going to deploy both services, the old one and the new one. And when I get a request, I'm going to send the request to the old one and also to the new one. But notice here the arrows. In the old one, there is a double arrow. It means that you send a request, and then you get a response, and this response is sent back to the user. But in the second case, in the green, there is only one direction. Because what it's doing shadowing traffic is a fire and forget. So you just do the request, and you don't care about the response. You're using this just to monitor the error rate. So if the error rates are not increasing, then you know that nothing is broken, and then you can start a blue-green or a Canary Release. Probably, if you are into microservices, you're using Kubernetes for deploying your microservice architecture. And I think that's the right way of doing it. And well, here I have a demo now. I'm going to use OpenShift. You just think that OpenShift is a Kubernetes for enterprises. It's just a Kubernetes. So it's exactly the same that I'm going to show you here works for Kubernetes. And what I'm going to present you here as a solution for testing in production is Istio. And basically, Istio is a service mesh. And a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. And of course, Istio is one of a service mesh. There is also others that I don't remember now the name, but I think that Istio is going to become the standard one. And I like to put this quote to really understand the scope of the program of Christian Posta, which is a workmate, which says that as we move to services architecture, which is a microservices architecture, we push the complexity to the space between our services. So in reality, microservices are easier to implement in terms of business, but you're moving some complexity between the services. And this is what service mesh are trying to fix. So this is the, let's say, the architecture of Istio. And let me put here. What you can see is that we have a service A. If you are into the Java world, this service A is running in the JVM. And then you have if you are in Kubernetes, you're running inside a container. And then we have a pod. And one thing that I really like is like, yeah, basically for the Spanish people, I said that when you think in a pod, you think about a pod to put things inside, right? But pod is a family of wells. This is the definition of pod, family of wells. And this means that you can run more of one container inside a pod. Because, this Docker thing that a container is a well, so this is why this is called pod. And then you have an Envoy sidecar container. Envoy is a proxy, like for example, HA proxy or Linkerd. But it's a proxy that offers some really advantages against other solutions that are currently developed. And then it basically intercepts all the traffic that is happening between containers. So when you want to talk, service A wants to talk with service B, instead of doing a direct request from service to service, with service to service I mean the Kubernetes service, it's done against the Envoy sidecar proxy. So Envoy just intercept all the communication and implement some cross-cutting concerns that we've seen before, like tracing, monitoring, or releasing processes. And now you see here at the bottom some parts. One part is the control panel, which is the one for managing and configuring the proxies. So of course you've got several proxies there in your architecture, so you need to configure them from a single point. You don't need to go to each of the pod and configure the proxy. We've got the Istio pilot, which is for storing and doing all this stuff. There is the mixer, which the mixer is used for collecting metrics from all the communication that happens on your mesh. And then there is also the Istio out that provides service-to-service and end-user authentication using mutual TLS between all your services. This is what Istio offers. And the demo that I'm going to show you, basically, it's the one that comes from Istio. I mean, that I can present any demo, but this is really simple, where you have one developed with Python. This is the product page. This is the front page. And then you have three versions of reviews, which is implemented in Java. The first one does not return, that returns the reviews, that's all. The second one returns the review with black stars as a rating. And the third one, it just returns the reviews, but now the stars are red. And then you have the details that is implemented in Ruby. So let me show you the demo. I've got here Minishift running. You can see, as I told you before, like OC is the tool for communicating with OpenShift cluster, but at the end, OC is like a wrapper of kubectl. I can do OC get pods, and you see that all the pods that are running, but I can do a kubectl get pods. And of course, it's not the same. Since it's a wrapper, you can use both kubectl and OC. And then I have here the application, which you can see that it's the comedy of error. You have a description of the book, and then you have here the details, and then here you have the reviews. And now you can just go here several times, and you will notice that always it's the same review. I'm getting the reviews B1 version. Now suppose that I want to do some dark lunch, and just the users that it's called JSON can try the service B2. So maybe you think about having to do some, modify some code and then deploy something or modify a file or something like that. You don't need to do anything. You just need to do OC create. If you are using Kubernetes, you will do kubectl create -f. And then, if I remember correctly, is this one. This is a YAML file that describes that if the user is JSON, then go to V2 instead of V1. But the rest of the wall still goes to the V1. So I have applied it. If you want, I can show you how these files look like. Now this is really simple. It just says, when I go to the review service, just if the header contains a field it's called that matches user equal JSON, then just route to reviews v2 instead of reviews v1. Of course, now if I go here and I start continuing navigating, I'm still just checking the version 1 because I'm not JSON. So I can now here go to sign in, I do JSON. And now JSON is equating to a v2, which has all these stars. Of course, I can continue navigating as JSON, and always I get it this. But then I can do just a sign out. And then when I do a sign out, again, I'm getting the version v1. And notice that I've not recompiled. No, I have not recompiled my program. I have not pushed any file. I have not modified any file. I have not changed the config map of Kubernetes, nothing. Just applying a Istio file just works. Of course, you said, OK, now I'm OK, and I want to just stop testing as JSON, so I can do just reviews test v2. So I'm going to delete the root. And for example, I can do kubectl get root rules, and you can see here all the list of rules that are there, and you'll see that now, if I have done this before, you will see that here will apply this new rule. Now I can go here, and of course I can continue saying this, and if I go here and I set JSON, of course, JSON is not going to v2 anymore. This one of the features, I mean, it offers a lot of features. Istio, I'm going to show you another example, which is, I don't know if I think that it's, what is? I cannot find it. Well, I'm going to. I don't know if I have deleted wrong, maybe. But maybe it's this one. Nope. OK, never mind, because now I cannot see where is the file. Probably it's in front of my eyes, but who knows? OK, never mind. I mean that I can show you, for example, this other another example of root rule rating test delay. And basically what I'm doing here, we can try it, in fact, is saying that, OK, now what I want to do is that when user is JSON, just route to v1, but add always a delay of 7 seconds. So between I go from service, product page, sorry, from details to review, when I'm getting from review to rating, add a delay of 7 seconds. So for example, I can just do OC create -f root rule ratings test delay. Now it's created, and if I'm going here and I log as JSON, Wait. Because now I need to see replace. Test. Okay. And now in theory. Okay. Okay. I see what's happening. Well, doesn't matter. I mean that you get it. You see that what I'm trying to show you is that you can modify the network without having to recompile or do nothing. And I don't know what is the example that I want to show you. I mean that it's a poltergeist that has disappeared. I'm really curious what's happened. Well, let's try. Okay, is this one? What I cannot... I know what's happening. It was in the... Okay. Yeah, I'm really smart, right? Yeah. Yeah. Now I know why. Okay. Live. Okay, well, now I'm going to show you, for example, just to not spend more time now that I've discovered this, that, for example, you can do something like that, and what you're saying is like, look, for any request that goes to the reviews, just send the 50% of the request to B1 and the 50% of the request to B3, for example. So you can just run this, and then you will get that 50% of each of the user. We can try it. Now that I've found it. And now it's, wait. Now look, it's green. Notice that now the 50% of the request goes from B3 or B1, and I've not done anything. So you can do the 50% and then replace to the 70% and so on and so far. So you can do a Canary release with this tier without having to modify anything. And so we are almost done. Well, I'm going to present, if you are into the Java and you want to start using Istio for Dart launches, we have Arcadian Cube, where basically you can do something like that you said, I want to apply this Istio resource, and this Istio resource maybe is the resource that says only JSON can access to the new V3, and then you can just do the request, I mean that an automatic test, and say, yes, of course, it works. So I'm running this integration test against my production environment. And then if it's success, then it just automatically replaces that Istio row. And let's wind down. The first thing is that I'm not saying that you don't need to write tests. You need to write tests, but as a whole, I mean that unit test, maybe you need to expand your view and say, not just unit tests, but also unit tests plus I/O. Also integration tests, of course, contract tests. And just forget about pre-production environments. I mean, that it's just a spend of money. And also, if you think about, in terms of money of the company, if you have 2 clusters, you're spending twice of the money just because you don't want to test against your production environment. Testing on production, it's hard. It's not easy. It's something that you need to do from scratch. So it's not like, I have this application with all these microservices, then I'm going to start testing on production, because it's not going to work. And it's really important to keep in mind, for example, what's happened with operations that are not idempotent, like, for example, when you do a post, right? In this sense, there is several strategies for dealing with this. And I suggest you to check two of Red Hat open source project, which is Debezium, which is based off Kafka, and also Tate, that allows you to create virtual DBs. So you can, with Debezium or Tate, you can do things like, I want to read things from my production database, but when the user needs to do a write, then this write is going to happen in this virtual machine, so not the production environment. So if you are using dark launches, then you can just remove all this data after the test. And if not, you can just do a batch process where it moves from this virtual DB to the real DB. And there is, and like this quote of Spock, which says like, change is the essential process of all existence. So you can still testing your microservice architecture as you have done before with monolith, like having end-to-end tests, smoke tests, regression tests, having your pre-production environment, doing manual QA and so on and so far. You can do it, or you can start doing this way of testing. And as I said, this is my Twitter, and this is my email. If you want to find more information about Kubernetes, OpenShift, and Istio, you can join. What? It's funny. Now? Yeah. You can join the developers.redhat.com, and you can send me an email or Twitter. Thank you very much. I will be around now during the coffee, so I mean that you can approach me and ask me
any question or like. Yep.
Hi. Regarding the dark launches, when you're shadowing traffic, what database are you hitting?
Yeah, you are hitting the production database.
Twice.
Twice. For this reason, I said that you need to use this Tate or Debezium, because it allows you to create some virtual DB where all the write operations goes to the database, to this virtual database instead of the real database. There is another, I'm not used Debezium nor Tate, because what I do, which serves me all time, was just saying, okay, I have a flag, like a toggle future, which says, look, this is a dark launch, and I just do transaction.rollback. It's really easy, but it works. So the first request commits the real result, and the request that comes from the shadowing traffic, it just roll back the transaction, always.
But you are assuming that the second one will be the shadow. And
because I'm deploying the B2 with a flag saying this is dark launch. Yeah.
Okay, so the first approach could be to just move the writes to another database.
Yeah, well, it's a virtual database at the end. Yeah.
Okay, thank you.
Yeah, you have both approaches. Yeah.
Hi, thank you for your talk. We have been playing with Istio in the past, and
I don't. Okay.
And I have two questions. First is Istio production ready? And the second one is cross namespaces?
Sorry, the last question?
Istio,
yeah,
in the past doesn't work cross namespaces. So
yeah.
We didn't use
Okay. Yeah, Istio works in different, because you can create several namespaces and then just install one Istio. Yeah, this works. And the second one about the production, it's a question it's quite difficult to answer. I'm saying that we in Red Hat in the OpenShift we are planning to start using Istio. That we have all the things, so we are almost there. But also I know some companies, some from here from Barcelona, that are using Istio in production. So if it's ready for production, I don't know, but there are companies, and we, as a Red Hat, are going to use Istio in production.
Hi. I would like to ask you about contract testing.
Yeah.
How do you integrate it in a continuous integration pipeline? Because it's two separate phases when you do the, I mean, it's totally isolated. And how do you validate that the results are okay if are totally isolated?
Yeah, you're validating that the results are okay because you have a contract. So your consumer is creating the contract, and then your provider, the contract testing framework makes all the checks against the real provider, and it checks if this provider is meeting your contract. So if the provider is meeting the contract, it means that the provider is okay, and the consumer is okay for sure because he's the one who has created the contract. And then how you do this in CI/CD? This is really, I mean, it's interesting, and it's in the book I've explained it, and also if you it's a matrix where you need to say, okay, I'm going to deploy a new consumer. So what I need to do is like generate the contract for the consumer that I'm going to deploy, right? And then go to the provider that is on production and replay this contract. If it works, then I know that I will be able to deploy my consumer to production, and it's going to work, because you need to test against the current provider. What's happening if you want to release the provider? Then what you need to do with the provider is say, okay, before I deploy provider to production, I'm going to start up my provider. Probably you're going to mock with using service virtualization the dependencies of this service. And then what you're going to do is just replay the latest valid contract on production. So at the end is that the contract that was generated by the consumer that now is on production, you're going to replay all this contract against this provider that is not in production yet. If it's all green, then you can say, okay, now I can move provider to production. I know it's quite, I mean, maybe it's hard to explain, but if you, when you see it, it's like, okay, it's logical what you're telling, yeah. But you get it, you understand what well, you can come to then and I can explain you.
Yeah, someone there. Well, there's two people actually.
Oh.
Yes, thank you for your talk. I have a question about the load testing. When you say that pre-production maybe it's not needed, I think that load testing maybe it's not a good idea on production. What do you think?
For load testing?
Load testing.
Load testing, yeah, performance testing, or yeah. We are doing currently there in Red Hat. And I know that you have said that you are, let's say, modifying the behavior of your users, right? Because probably everything will go a bit more slower than expected. But my question is, why do you want to have some data or some results that are not true? Because your pre-production environment is not the same as your production environment. So you can say that, well, you have an idea if you are improving or not. Yes, but I mean, why? Yeah, what I want to do is the real numbers. And I think that the best way is using the production environment. And again, if you're thinking about 10 services, okay, it's fine. But if you have 10, I mean, that I know some companies that have like 100 services. So if you think about deploying 100 services in a pre-production environment, you see that it's a cost in maintenance, but also in the cost of if you are using, I don't know, any cluster provider or any cloud provider, then you need to spend all the money or the traffic money for this. So I will say that we are doing, and we prefer doing in the production environment.
Question about database still. Is it something that is more for non-SQL database or more adapt to NoSQL database, or relationship database is fine with the system as well?
Yeah, I mean that Tate and Division, both of them, supports all the, I mean, not all, but I mean that for relational databases, I mean that it's supported. And for NoSQL databases, I know that there are supported. I cannot say if all, I mean, all of them probably not, but I cannot say now this one not, or this one yes or no. But yeah, I mean that it works with NoSQL and SQL databases.
Okay, thank you.
No.
Hi, I'm interested in the fact you talk about the database, the CERT to talk about this. I think it's a very big concern. When you do Canary test or when you do a switch green and blue, is there a way to come back to the previous state? And does that mean I have to make some script more than the simple basic step? No?
Yeah. It's like that way. Yeah.
So we have some risk to put some complexity where there was.
Again, if you are, I mean that. I think that the best approach to avoid this is first dark launches. Then in this phase is where you say yes. I know that we are. I mean that probably it's going to work because I tried with I don't know with my internal users or with shadowing the traffic, and so it seems that it's going to work. So then I can move to there. You can do you can do Canary releases with virtual DBs as well if you want. Yeah, I've not tried, and the truth is that in our case, what we have is like a script to roll back everything or move. So most of the time, it's a problem when you modify the schema of the database. This is where you have the problem. If you don't modify the schema, well, yeah, you can delete it easily. The problem is when you modify the schema, but yeah. But at the end, you have a script that manages this thing.
And also, I didn't understand the second name. There was...
Divisium and Tate.
Tate.
T. You're welcome.
Excuse me, just
here.
The detail.
No. Divisium and Tate. Oh. No, this is the T-E-I-I-G.
I-G, okay.
Yeah.
Thanks.
Okay, well, you can come. I mean, I will be here in the coffee, so feel free to ask me anything. Thank you very much. Okay, bye.